sigma notation. The Greek letter uppercase sigma looks something like this, is used to represent a sum. So this one, it says k equal 1. You read that as k goes from 1. As k goes from 1 to n. So the sum as k goes from 1 to n. This one would be the sum as I goes from 2 to 50. K and I are called the index of the summation. Index could be I, J, or K. It doesn't matter so much. I will usually use K because I think it shows up better on the screen. It's more it's easily to distinguish it from something else on the screen. I and J kind of look like each other, and they also look like a 1 a little bit. But so K, I'll usually use K. So anyway, here we want the summation as k goes from 3 to 7 of k. So this is going to be just 3 plus 4. It's all the numbers from 3 to 7. So it's going to be equal to 3 plus, whoops, I did 7 already. 3 plus 4 plus 5 plus 6 plus 7. So 3 plus 4 is 7. 5 plus 6 is 11. 7 plus 11 is 18. 18 plus 7 is 25. So the total is 25. You can add these in any order. The order doesn't matter for addition. The second example, the sum as j goes from 1 to 4 of j squared plus 2 times j. So we'll do, start with 1. We'll do 1 squared plus 2 times 1. And then when j is 2, it'll be 2 squared plus 2 times 2. And then when j is 3, we'll have 3 squared plus 2 times 3. And when j is 4, we'll have 4 squared plus 2 times 4. So 2 times 1 is, 1 squared is 1, 2 times 1 is 2, 1 plus 2 is 3. 2 squared is 4, 2 times 2 is 4, 4 plus 4 is 8. 3 squared is 9, 2 times 3 is 6, 9 plus 6 is 15. 4 squared is 16, 2 times 4 is 8. Okay, so, and then, so we can add these. This is 11, this is plus 31 plus 8. And we can add these in any order. It's 42 plus 8, and that's equal to 50. Okay, so the sum there is 50. Okay, so another example. This is actually, we'll use sigma notation for some of our statistics. Sample mean can be expressed using sigma notation. So the mean we have 3 exam scores, so it would be the sum as k goes from 1 to 3 of each exam score, xk, all over 3. So that's x bar represents the mean. So this is going to be the sum as k goes from 1 to n, 1 to 3 of xk. So that's x1 plus x2 plus x3 over 3. And the first score is 87. Second score is 78. Third score is 90 over 3. 7a is 15. 5 carry 1. 1a is 9. 7 is 16. And 9 is 25. So let's double check here. 7a is 15, carries 1, 1a is 9, 16, 25. Okay, so it's 255 over 3. 3 into 255. 3 doesn't go into 2, goes into 25 8 times. 8 times 3, 24. Remainder 1, bring down to 5. 3 into 15 goes 5 times. So the mean of those scores is 85. Okay, so here, example 4. Here we're using sigma notation to denote the weighted mean. So it's the sum as k goes from 1 to n of each score times its weight. So it's going to be x1 times its weight plus x2 times its weight plus x3 times its weight. So they'll give us 87, and the weight is 0.2, plus 78, the weight is 0.2, and 90, and the weight is 0.6. So let's see, 87 times 0.2, 14, carry the 1, I think 17.4, 17.4, 78 times 2, 16, 15.6, 0.6 times 90 is 54. If we add these, get 33 plus 54, and that's equal to 87. So the weighted mean under that weighting system is 87. If the comment here, if the weights don't add to 1, we also have to divide by the sum of the weights, but these weights add to 1. 2.2 plus 0.2 plus 0.6 is 1. Okay. If the weights don't add to 1, then we have to divide by the sum of weights. That's expressed by this formula here. In the numerator, we have 3 exam scores. So the sum is k goes from 1 to 3, xk times wk. So each score times its weight. And then in the bottom, we have the sum of the weights. So this is going to be x1 times its weight plus x2 times its weight plus x3 times its weight in the numerator. In the denominator, we just add up the 3 weights. So this is going to be 87 times 1. 87 is weighted 1. 78 is also weighted 1. And 90 is weighted 3. And then we want to add the weights 1 plus 1 plus 3. So 87 times 1 is 87. 78 times 1 is 78. 90 times 3 is 270. 1 plus 1 plus 3 would be 5. So let's add the numerator. 7 8 is 15, carry the 1. 1 8 is 9, 16, and 7 is 23, carry the 2. 2 and 2 is 4. So 435 divided by 5. Double check here. 8, 7, 15. 1 8 is 9, 16, 33, 43, yep. So 435 divided by 5. 435. 5 doesn't go into 4, it goes in 43 8 times. 8 times 5 is 40, remainder 3, bring down the 5. 5 into 35 goes 7 times. 7 times 5, 35. So the weighted mean under that weighting system would be 87. So, later in the course we'll be using sigma notation for more complicated formulas. And these are all important statistics here. The sample variance, summation is k goes from 1 to n. Each score minus the mean, square it, divide by n minus 1. And sample standard deviation, the square root of that. Those are both measures of how spread out the data is. And then the correlation coefficient measures the relationship between 2 variables. For example, the weight of the car and the number of miles per gallon it gets. The heavier cars usually get fewer miles per gallon, so the x variable could be the weight, and the y variable could be the mileage. Okay, so for each variable you would have a mean x bar, standard deviation sx, or mean y bar, standard deviation sy, and you would compute the z-scores for each variable, multiply them together, and then add up these z-score products, and then divide by n minus 1 to give you the correlation coefficient. But we'll be getting into that later in the course. For now, we're just using the sigma notation for mainly for the mean and weighted mean and also just some examples of that don't have these first couple examples don't have any particular application, but just getting used to the formula, getting used to the sigma notation. Okay, so that concludes this presentation.